So let's talk about temperature now. We're gonna be doing some math here in this section. We are going to be considering temperature. Appreciate please that temperature is the measure of how hot or cold something is, of course, and it's measured with the thermometer. Let me go back a slide. I did want to say what the learning goal was for this. The learning goal for this section is that we're given a temperature. We're going to calculate a corresponding temperature on another scale. For example, we might find degrees Fahrenheit, or we might be given degrees Fahrenheit and be asked degrees Celsius, or we might be given degrees Celsius and asked how many kelvins do you have, right? So there's three different scales that we're concerned about: Fahrenheit, Celsius, and Kelvin, and we're going to convert between those two. The core chemistry skill is here. Let me get my highlighter. The core chemistry skill is converting between temperature scales, okay? So first of all, the temperature scale between Celsius and Fahrenheit. Celsius and Fahrenheit, right? The temperature difference between boiling and freezing, and both of them are divided into smaller units called degrees, right? On the Celsius scale, there's 100 degrees between boiling and freezing. And on the Fahrenheit, there's 180, right? So that means that the degrees in Fahrenheit are actually smaller increments because they're divided up more finely. Right, so the Kelvin scale, there's 100 degrees, there's 100 kelvins between boiling and freezing, but scientists, so first of all, let me read this. Scientists have figured out that the coldest temperature possible is negative 273 degrees Celsius, okay? Now, since that's the very coldest temperature possible, we've given it a name called 0 kelvins, okay? So can you see that degrees Celsius minus 270, or rather, plus 273 is equal to kelvins, right? Because these two are equal to each other, right? And they have the same size units as Celsius. Okay, so let's look at a couple. Here's a graphic to make you help you appreciate that. A comparison of Fahrenheit, Celsius, and Kelvin temperatures. So if we've got ice water here, or actually this looks like this is boiling water. Sorry, that's steam coming off. Steam coming off, okay? If you've got boiling water, well, it's 100 degrees Celsius for all three of them, right? But we call that 212 degrees Fahrenheit. We call it 100 degrees Celsius, and we call it 373 Kelvin. Same temperature, right? We just call it different things, right? Okay, so let's do a learning check real quickly. And I'm going to decline that. That's my son calling. And I'm going to decline that. Let's do a learning check real quickly. And pause the video, choose the answers for these, and come back. Okay, let me suppose you paused it. Let's talk about freezing. Freezing of water is 0 degrees Celsius, right? It's not 0 Fahrenheit. That's 32 degrees Fahrenheit. And it's not 0 kelvins. That's really 273 kelvins, right? Okay, so it's 2. That's the correct answer here. What's the temperature at which water boils? It's not 100 degrees Fahrenheit. It's not 32 degrees Fahrenheit. It's 373 kelvins, right? If it's Fahrenheit, it's 212 degrees Fahrenheit, okay? So, which is the same as 373 kelvins. Okay, how many Celsius units are between boiling and freezing points of water? How many Celsius units are between boiling and freezing points of water? It's 100, right? 180 is Fahrenheit, and 273 is the difference between that, right? Okay, so let's do a conversion now. So first of all, to convert between Celsius and Fahrenheit, we first of all should appreciate that there's 100 degrees difference between freezing and boiling with Celsius, but it's 180 between them. So this is a decent ratio to say that there's 1.8 degrees Fahrenheit for every degree Celsius, because it takes that many more to get from boiling to freezing, right? So let me just fast forward and say that here's the formula for converting Fahrenheit to Celsius. Fahrenheit is equal to 1.8 times Celsius plus 32. Okay? And if you want to go the other way, you just rearrange the equation as I've done here. I didn't do that. I got that from someone else. You just rearrange the equation, and you find it. You can put Fahrenheit in here, and you can get Celsius out. Okay? So let's do an example. I'm going to put the equation here to help you see through it. I'm going to pause the video. You should work through this and then come back and see my answer. Okay, I'm going to suppose you paused it. I'm going to do the answer here. A person with a hypothermia, right, dangerously hot, dangerously low temperature, body temperature, is 34.8 degrees Celsius. Okay, what is the temperature in Fahrenheit? T sub F is equal to 1.8 times 34.8, right, plus 32. And this is going to be equal to, let me grab my calculator, 1.8 times 34.8 plus 32 is going to be 94.64. 94.64, okay? But you can see that this only goes to the ones place, so I have to round this to the ones place. So this is going to get rounded to 95, right? Because whatever this number is, I don't even know what it is, but I'm gonna add it to 32, right? Remember I told you I'm always gonna do that dotted line right there, okay? And so this comes out to be 94.64. But since we only go to the ones place here, I can't report any more precise than that 95. So it's going to be 95 degrees Celsius. All right. So let's look at some comparative temperatures. If we look at the sun, it's pretty hot. I would say if you go and stand on the surface of the sun, you're gonna get hurt. Okay, so that's 9,000 degrees, or 10,000 really degrees Fahrenheit, right? If it's only 5,000 degrees Celsius, I'm just kidding. It's the same temperature, right? And you can see it's about the same in kelvins. A hot oven, yeah, don't stand in a hot oven either, even though it's way cooler, right? Wow, that's a nice cold day. If you compare it to the sun, still too hot though. 230 degrees Celsius, 450 degrees, depending on what you're baking, right? And 505 kelvins. Okay? High fever, right? Normal body temperature, absolute zero. Okay? Water freezes at 32, 0 or 273. Okay? So it's kind of a nice table. This is from your textbook, table 3.5. Okay, so let's do a couple learning checks and we'll wrap this up. On a cold winter day, the temperature is minus 15 degrees Fahrenheit. What is the temperature in degrees Celsius? Pause the video and come back and see my answer. Okay, I'm going to suppose you pause the video. I only have one of these formulas memorized, okay? 1.8 times the temperature in Celsius plus 32. So I know that TF minus 32 divided by 1.8 T Celsius, right? So let's come here with a different color, and let's say Fahrenheit is minus 15 minus 32 divided by 1.8 is going to be equal to, let's do that, 15 minus 32 divided by 1.8 is equal to negative 26.111. Negative 26, oops, whoa. Negative 26.111, and so on, right? So how many sig figs is this? This is going to be 2 sig figs up here. This is going to be 2 sig figs down here. So this number has to be reported to 2 sig figs. And so this is we're going to say that this is about minus 26 degrees Celsius. All right, let's do one more and then we'll wrap it up. Again, pause the video, look at the question, pause the video, and come back and check your answer with mine. Okay, let me suppose you pause the video. Don't forget, a degree Celsius plus 273 is equal to kelvins, because Kelvin can't go below 0, right? But Celsius can. So what's the degree in kelvins? So this is going to be 37 plus 273 is going to equal to, looks like it's 310, doesn't it? 310 Kelvin. Handwriting is really bad today. All right, 37 plus 273. Doing it on my calculator just to be safe. In fact, it is 310. All right, so that's an introduction to temperatures and how to convert between different temperature scales.